Hi, this is chapter 15, chapter review questions. I want to make sure you know how to write an equilibrium constant expression. Don't get confused with the rate law. This is an equilibrium constant expression. So you have two kinds of equations. You have homogeneous equations. That means all of their things are in the same state. So this has all gases. This is homogeneous. This isn't a heterogeneous one where these are solids and these are gases. So the states of the reactants and products can be mixed up into different things. Now, the most important thing you want to remember is when you're writing an equilibrium constant expression, you only use gases and aqueous. You never put a solid or a liquid, because when those amounts change, like if you add more solid to the bottom of a solution that's already saturated, none of that is going to come out and react because it's already saturated. So solids and liquids are not going to affect the equilibrium constant expression. Okay, your book explains it pretty well, and so does the videos. So equilibrium constant expression is K, and I'll put EQ for equilibrium constant. There's KSP, there's KA, there's KB. There's lots of equilibrium constant expressions, and they're meant for different things. So always put the concentration of the products on the top, and concentration is in brackets, and the number of moles becomes the exponent. So that would be N2 squared over O2, with O2 on the top, and on the bottom you would have N2O squared. Now, when they give you equilibrium concentrations, all you have to do to find the constant is to plug those numbers in, and don't forget to square them and do mathematically what you should do. So when you get to ones like 14 and 15, you write the equilibrium constant expression and then plug in the equilibrium amounts, the concentrations, in for these things. If they want to know the equilibrium amount of something, they might give you the constant, and then you just solve the equation for what's missing. Okay, this one, what do? Well, we don't put solids in there, so this basically would just be H2O and CO2 over 1. So this would be the equilibrium constant expression for that. Okay, products over reactants.